So, welcome everybody. My name is Heli. Today we talk about machine learning. I really love the sign outside saying Heli Machine Learning. So yes, this is Heli Machine Learning. First of all, I will start this. Very briefly about myself. So my name is Heli Helskyaho, but nobody can pronounce the last name, so I'm called Heli from Finland. And the reason for that is that I do come from Finland. So I'm one of those speakers that has a very short trip here, direct flight, less than an hour. So yes, I'm from Finland. I have graduated from University of Helsinki with a master's degree on computer science and currently working on my doctoral studies. And those studies are related to machine learning, and that's why I've been studying machine learning quite a lot lately. I've been working with Oracle products since 1993. And actually on IT since 90. Welcome. We still have some seats left. I'm very surprised this is so popular. Anything to do with data and databases is very close to my heart. And that's probably why I ended up with machine learning, because it is all about data. I'm a CEO for Miracle Finland, which is a small consulting company in Finland. Oracle ACE Director, Ambassador for EMEA user groups, including Latvian Oracle user group. Listed one of the top IT influencers in Finland 4 years in a row. Don't ask me why, I don't know, but I'm very proud and happy. A speaker and author. I have written 2 books, the first one by myself about database designing, and the second one with 4 other people about SQL and PL/SQL. I'm a member of the ACE program, ACE Director. There's 3 tiers on that. There's the ACE Associate, ACE, and ACE Director. If you're interested about the program, I'm happy to tell you more. And there's the link in the presentation to find more information about it. But then to the topic. So what is machine learning? What I found very interesting when I started with machine learning was that there was not really a definition for machine learning that everybody agreed. So I decided my first job is to find a definition that I agree about machine learning. So I worked on that. In general, machine learning teaches computers to learn from experience, the algorithms, and the data. It's a field of study that gives computers the ability to learn without being explicitly programmed. This is what Mr. Arthur Samuels said in 1959. 1959. And now suddenly everybody is talking about machine learning. There's actually 2 reasons for that. The first one is that we are finally able to do those things that he was imagining in 1959. Because of the storage space is so cheaper, the computer power is much different than it was those times, but also because we are forced to use machine learning. We need to make quick decisions based on data, and we don't have really time to analyze it manually and spend a lot of time with the data. We need computer to do it for us. So we need machine learning to give us the ability to make decisions quickly based on data. It is a systematic study of algorithms and systems that improve their knowledge or performance with experience. So these are the definitions for machine learning that I kind of like. I am sure some people disagree, but this is how I see machine learning. So what is this machine learning? Where can I use machine learning? Some real-life use cases that I'm sure you have already seen is a spam filter. So spam filter is something you cannot program if, else, then, whatever. It's something that changes constantly. The rules are changing all the time, and there is no way a developer can be there doing all those else's for the program. So we need machine learning that will adapt whenever the data is changing, whenever something is changing in the world. So spam filter is a very classical example, as well as log filters or log alarms. Data analytics, image recognition, speech recognition, medical diagnosis, robotics, fraud protection, fraud detection, product, music, movie recommendations, all these kind of things are the things that for some reason it's no point trying to program it manually. So it's much better to use machine learning and artificial intelligence. A very simple example of machine learning could be a chatbot. Do you know what's a chatbot? You order a pizza using a chatbot. So you use the Facebook Messenger, you send a message to your pizza place, you order the right kind of pizza you prefer to have, and they will deliver it to your house. The first time I tried that, I managed to do it. I'm the kind of person, when I touch computers, they break. I'm very good. I should be a tester. I would a natural talent on that. So I ordered the pizza using Chatbot because I wanted to test how they work. I managed to get a pizza, but of course it was the wrong kind of pizza. So, well, kind of success. The other pizza was good too, but not as good as the one that I wanted to have. You could use this for any kind of customer service things, like finding the bus schedules, finding what is the best way to get from here to there. All these kind of services could be chatbots. Or it could be helping your students to find the studies that they should be taking, finding the courses that are available, that kind of thing. So something quite simple that you would normally need a person to help this student, but now it could be done with an application, a chatbot. My favorite of all these chatbot is WooBot. It's a kind of therapist that you can chat with, and it's very funny. So if I'm bored or I feel sad or anything, I start chatting with WooBot. I don't know if it's he or she, so maybe it's an it, I don't know. But it's really fun. So if you haven't tried, please do. I was thinking to demo, but it was so complicated to change phone and laptop, and so I just decided to use the laptop. So no demo today on that. But really try that. It's very, very fun. You just send a message to WooBot, and he, she, it will be replying to you, and you will be chatting. Very, very fun. So other real-life use cases for machine learning. Online shopping, Amazon. It will do searches, it will do recommendations automatically for you using machine learning. Voice to text. So I'm speaking and it's translated to text. That is using machine learning as well. Personal assistants, those smart personal assistants like Siri, Google Assistant, Alexa, Echo, Cortana, all these things. You just talk and it will help you. Or he, she, it, I don't know, again what. So you just take your phone and you say, find me the recipe for bread, or find me the nearest grocery, and it will help you. By the way, why do we do like this? I speak like this to you, but when I speak to my Alexa, I'm like, find me the nearest grocery. So I pretend I'm a robot. Seriously. And I'm not the only one doing this. I have seen other people do the same, but very funny. So we kind of try to adjust to the situation. I'm not talking to a human being, I'm talking to somebody else. Facebook is also a very classical example. I will tell you something about Facebook in the end of the presentation. So I was thinking I share you first my own real-life use case for machine learning. So I was having a flu home and I was not able to work. So what do? You program, of course. That's a nice thing to do when you're having fever and you're not feeling well. So my husband already programmed, he's a developer as well. Surprise. So he already programmed the house alarm system for us using Python, and we decided we should have a face recognition for that. So when somebody comes to the door, it will recognize there's a face, and maybe it will even know if it's somebody we know or somebody we should be afraid of, a burglar maybe. So we should have that in our home alarm system. So let's do something about that. So we'll just extend the Python system we already have with this new functionality. I will show you what happened. Do I have it here? No. Somewhere. I have so many things here now. I don't know how I'll find it. Come on. I will find it from here. Image recognition. So this was a very simple example because I was only sick for one day, really. So didn't have much to do. Yeah, you can see it. Yes, yes. So this is what we had. We had the camera. So there's a small box here that we had the Raspberry Pi that we put inside the box. It will have also a camera. I put the pen here so you can see the size of the thing that we have here. It's not very big. This is what it looks like. This is one of the old versions, so this is very cheap and not very capable of doing many things, but it's capable of doing face recognition. Here's the code very briefly. We actually copied it from this page because we are thinking we do something quickly. Then we changed a little bit of the code, so it's already pre-trained. We didn't need to train the code at all. Or we didn't need to train the thing at all. There was enough information so that the algorithm was already working well enough for us to recognize the faces. This is us, me and my husband, sitting in our living room. See, I have the blanket because I was having fever, I was feeling sick, but I wanted to test if it works. My husband is having the computer to start it. And so the idea is the camera, when it sees the face, it takes a picture. Otherwise, it's not taking pictures. Now it takes a picture of us, and it circles here 2 faces. Wow, it's working immediately. We were very happy. So we were thinking, what if we put more light? Will that affect? And because we were already told that it's been taught to recognize faces straight like this. But what if it's a half face or sideways or something? Will it recognize the face? Because I'm sure the burglar doesn't come like this. No. So we have to be prepared for everything. So we tested. I took a book with a Trump's face on it. It's just a half face, not the whole face, half face of Trump. And I took the book and hold it like this, and we test what happens. My husband starts the program. Here we go. 4 faces. It was like, what? So again, we are 2 faces. Trump is a face, even though he's half a face. But what on earth is this? It's a carpet. It's the curtain. Why is that a face? We still don't know, but I have a theory. Somebody told me when I was showing this picture, there's a ghost here, which we can't see, but the program does. Or maybe we haven't trained it well enough. Maybe we need to train it a little bit better. But anyway, I was happy about this, unhappy about that. But then I was well again, and I needed to go back to work. So we are still in the middle of a process of making this better. Are we? Yes. Oh, this works brilliantly. So this was my real-life use case for machine learning. Very simple to implement because somebody already programmed it, somebody already trained it. It was very easy just to use it. So what I'm going to show you next is in-database machine learning. In Oracle, you can do in-database machine learning. It's a licensed product, but still I will show you how it works because I'm sure many of you already know SQL and PL/SQL, so it would be good to know a little bit about it. Why I want to talk about in-database machine learning? Because why would you move the data? It's much easier to bring code to the data. So bringing the data to the code is a lot of work and a lot of hassle. Bringing the code to the data is much easier. That's why I prefer preparing the data and doing everything with the data where the data exists. Is it the database? Is it Hadoop? Wherever it is. Much easier to do where the data lies. Preparing the data is the hard part. Most of my examples I will show you here, I fail because my data is not good enough for some reason. So I would say 80% of machine learning is preparing the data. So if you're a database person, you are pretty good because you are doing the same thing you have been doing before with machine learning too. You are preparing the data for something. 20% is the rest of the stuff. This is not scientific proof. This is my feel of thumb. Maybe you already know SQL and PL/SQL. Then these are very easy to start with because machine learning is about so many things. So I think the worst thing you do is to start with a new programming language. So your first machine learning project, you take a new programming language, you start with machine learning, and you will be so frustrated because it's so much different things going on and you don't like it. So start with a programming language you already know, and then try machine learning on top of that. When that comes familiar to you, then you can take another programming language. This is my opinion, and this is what I learned when I was trying to understand how machine learning works. What I liked very much was that when I was doing in-database machine learning, I was able to use Apex. You know, Oracle Database has this Application Express tool that you can, or environment, or how would you say, low-code product that you can use to build applications. You can use that same Apex to visualize the data and the process and everything, and it was actually very handy. So I kind of liked that as well. So that was one big plus for me to doing my machine learning in a database. And also the deployment will be very easy because what I will deploy here, everything will be tables, views, PL/SQL packages, functions, procedures, and those will be easy to use from database with any programming language that can connect to my database. So I kind of like this in-database thing because of those. One possibility to do that is using Oracle SQL Developer, which is a free product from Oracle. You just install and start using. You can connect to an Oracle database and do a lot of things with it. If you want to use Data Miner, that is an option that you need to pay for. But I put here some links if you want to do that. I will show you one example here. So I want to find those customers that are most likely to buy an insurance. So I run an insurance company. I have a lot of unfortunately, a lot of customers who has not bought this insurance yet. So I don't want to call all of them. It will be like 200,000 calls. I would rather call those customers that are most likely to buy the insurance. So I will have a shorter list to call. How do I find those? I have a very small demo about it. Let's see if I can find the right place here. No. It's the demo. Now not showing. Should I? Now I'm shutting down the system. Okay, I will not demo that. I pressed the completely wrong combination for that. So we will just go back to the slides. That's fine, thank you, no problem. So I will just show it here. This way it works as well. So I'm prepared for everything. I have slides of my demos as well. So this is how it goes. So the tool is a drag and drop tool. When I'm using it, I don't have to know anything about algorithms or models or anything like that. I just drag and drop things. So first of all, I drag and drop my data here. This is my example input data, known input, known output, because I'm doing classification. I have customers who has bought insurance. I have customers who has not bought insurance. Which of those customers who has not bought insurance would like to buy it? Based on the information, these customers already bought it. So I will take my known input, known output data, I will explore the data using the explore data functionality. It will analyze it for me. It will show me all kind of diagrams like, does the age affect? Does it affect if this person is very wealthy? And so on and so on, and combining different things. So I can see graphs about how different things affect the decision of buying or not buying insurance. So this is the part where I've spent a lot of time to understand how the data is correlating. Then I will use my data and use a classification, a model here. So the tool has several classification algorithms it's using, and I can just see which of those works best with my problem, my task. So I drag and drop here class build. I use this data with my class build, and then I will just see how it works. So what kind of results each of these algorithms is given, which one of them is very accurate, which one of them is very efficient, very fast to learn, and so on and so on. Based on what I find here, I decide, okay, I'm going to use decision tree because that works the best. I take new data, new input data, and I apply the model and algorithm I just chose here to that data, and I get my prediction. These are the customers that you should be calling, and these are the customers you're wasting your time if you are calling them. Then I can implement this as a table, as a view, as a column, as a whatever structure I want to implement to my application. Okay? Very simple and classical example of machine learning with a tool that you don't have to know anything about programming, anything about machine learning. Well, a little bit about that, but a lot about your data to understand if it makes sense or not. So understanding your data is crucial part in any machine learning thing. So I just drag and drop things and I do my predictions. One possibility. My next one is I have a university. By the way, I do work for university as well. And I want to know how many students will enroll the course. So who are the students that will enroll this course next year? So I know if I need a room for 10 people or 150 people. For this demo, I will use Oracle Autonomous Data Warehouse. I will just show some slides because I have some difficulties to connecting to the database now. I don't know why. So in Autonomous Database or Autonomous Data Warehouse, you can use Apache Zeppelin-based machine learning SQL notebooks, which is a good improvement already. So I have notebooks available. What it also brings me is all kind of graphs. I told you 80% of my problem is to understand the data. So using this Autonomous Data Warehouse, I'm able to analyze the data and understand my data with all kind of graphs very, very easily. Just like I was able to do with SQL Developer, I'm able to do it here. I don't have to program anything myself. It's all already built there for me. So I can just analyze the data before I make my decision how I will move on. One of the decisions I have to make is which of these columns really affect the fact if this student will enroll the course or will not enroll the course. So finding the right attributes, columns, facts that will affect is very important decision, and I can make it based on this kind of graphs to understand my data. One of my favorite, I don't even drink beer, I still love this example. This is the demo I built together with my husband for Germany, Bonn, when I was presenting there at the Apex Connect about a month ago. The thing was that I need to predict an overall rating for a beer. So I run a pub, and I want to decide if I should buy this beer or that beer. So which one will be something that my customers would like? So for this demo, we used SQL, PL/SQL, and Apex. Apex was mainly used to understand the data and understand the process and understand which of those algorithms was the best. So I don't go to details on Apex on this because I don't have so much time. But I have another presentation about this. Maybe I will come next year and talk about beer, very funnily. But here in this demo, the thing was that we needed to find a probability for beer number something to get overall rating 5. So the rating is between 1 and 5. So what would be the possibility that my customers would love this beer? So should I really buy this beer to my pub or not? Here, the difference between this is what kind of attributes I use for predicting it. I'm using all the attributes available or just style. So this was to find out if I should buy this particular beer. Another question I had in my pub was that what are the brewers that I should contact? So those that will probably make number 5 beers. So what are the best brewers that I don't sell in my pub yet that I should be selling? So with that, I will find those brewers that probably have good beers, and I will call them and I make agreement to sell their beer in my pub. Then another kind of task. I run a telco company, and I kind of have this fear that some of the customers will leave. But I want to know it before they leave, because I hate the situation they just change to another company, and then I have to go after and say, please come back, I have a good offer for you, please, please. And the customer will say, you didn't do anything last week, why are you so interested today? I'm not coming back. So I want to avoid that moment, and I want to contact them earlier and make them stay. So how do I know who those customers are? For this demo, let's see if I can get it from here. No, it doesn't want to show it. Okay. This is the, okay, let's see if it comes. So for this one, I was using Python. Well, it doesn't matter what language you use, because all these languages, they have their libraries for machine learning. And if we can't get it working, no problem, then I will just talk. But this is such a sophisticated system, and I'm trying to, I told you, I break everything I touch. Here we go.
You have to go out from the PowerPoint.
Ah, okay.
So it captures the screen.
Okay.
Which was this one?
No, I will find it, no problem. This is the next one we will see. So this is my telco customer example. I don't go to details on it. I just show you how it would look like if you're using Python, if you're using this kind of thing. The reason I told you don't start with a new programming language is because you will fall with stupid things with a new language. Like what I did with Python. First of all, I told you SQL and PL/SQL is my background. I'm not case-sensitive person, seriously. But Python is case-sensitive. R is case-sensitive. So I always hit with the case sensitivity because I'm not prepared to that. What I also hit is I'm trying to read my file in here, and it says invalid argument. What's wrong with my argument? I'm giving you a completely perfect file. Why can't you read it? The thing is that it's thinking that I'm here using a tabulator. So it sees it's a tabulator, not the real backslash. Took me a while. My husband knew it immediately. He said, ha, 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 it's the backslash. It thinks it's a tabulator. It doesn't read the file name. It stops here. And because the previous one was working perfectly well, there was no problem. And suddenly there's a problem because of that. So you end up with very strange things that are something that person who has been using that programming language will not face, but you will as a new user. So whatever language you use, you read the file in, you analyze the data, you try to understand your data. There's different kind of ways you can do it. Here I'm using shape, I'm using head. Shape gives me how many rows, how many columns. Head gives me the first 10 rows or the first how many rows I want to have. Tail gives me the rows in the end to understand what my data is about. Describe it, how does it look like? Here the count. So this describe is a very good command. You will understand a lot about your data. 75 percentile, 25 percentile, min, max, and so on. So this is about understanding the data. Just need to take a sip of water before I start coughing. So understanding the data is number one thing. Whatever language you are using. Then after I understand my data, I realize that actually, well, we'll go a bit further. Oh, I can also see all kind of graphs about it to understand it better. This is probably something I need to do because if I have 1 billion rows, doesn't tell me much. So having all kind of graphs will explain the data better to me. So I'm still understanding the data here. Because I'm going to do a classification example where I need to have two sets, the training set and the testing set. I can't use the same data for testing when I build a model using the training set. So I need to separate the data in two sets. Let's say 65%, 35%, whatever percent it is, divided in two. So this is a thing called supervised learning, if you're familiar with the term. Supervised learning and classification. And this is something that is a very, very principal thing. Then I realized I have data types that my algorithm doesn't understand because it only understands kind of numbers. So I have different kind of things. So I need to convert some of my data for my algorithm to understand. And when I'm done with all that, I start doing my predictions. I will just skip many, many things so we can see other things as well. And finally, I will predict what are my customers and so on. But this is how to do things with, let's say, Python. I could also use, this is not a smart move because now I'm changing between this again, but I could also predict the house prices. Again, I'm using supervised learning, but now I'm not doing classification, putting in classes. I'm going to use regression, predicting numbers. So I'm going to use R to predict the house price. Let's see how I can do that. I go this very quickly because it's not the idea to go every line by line, just to understand that there are so many options for you to do these things. Here I have an R program. First of all, I have my data. So I'm trying to understand my data. I have ID, I have date, I have price, number of bedrooms, number of bathrooms, square meters or square feet. This is American data from King County. Waterfront, view, condition, grade, all kind of different sizes of the house, and so on. So first of all, I upload this data to my system. I read it. By the way, I always use these libraries. In R, you say library and then the library name. In Python, I was using import. So, but it's the same thing. It's giving me the ability to use libraries somebody else has built. By the way, for me, it's always a very difficult thing, not invented here. Somebody else wrote a library. Does it really work? What if he changes it? What do I do then? So there's always this thing, but I'm sure you're all aware of this. A very fun dilemma. So I'm reading the file. I'm printing it out to understand what kind of data I have here. I will take a very serious look of the data with all kind of possible ways, using all kind of histograms, using this and that, trying to understand how it's divided, what factors What are the factors that will affect the price? Is condition the most important thing? Is the size of the apartment the most important thing? Is the location the most important thing? And so on, trying to predict what are the factors that will affect the price of the house. By the way, there are very funny facts about that. So about the size will affect, but only until a certain point. When the house is bigger than that size, it will actually make the square meter price lower. But when it goes after that, it gets higher again. It's very weird. So very big apartments can be very expensive by square meter, but the medium size can be cheaper, and the small ones are very, very expensive. My son said there's explanation from economist about this, because those people who will buy those enormous houses, they don't care. They have all the money. And those who are buying the middle-sized houses, they are the families, they do care. So they know about the price and they negotiate the price and so on. So that's why it goes like very funnily, the pricing. I don't know. But it's very fun to find this kind of facts and then trying to reasonize why is it like that. So here I'm doing all kind of trying to see if the condition is 1, 2, 3, 4, 5. 5 is in a very good condition, 1 is in a very bad condition. So how does that affect the price? And so on and so on. So using all kind of graphs is very important. So whatever language you are using, it would be good to have some kind of graphs available. Then I do some conversions to have it in logarithmical way of showing. I do some graphs about it to kind of understand it in another way. Different kind of graphs. So see, understanding the data is the thing. After I understand the data, I'm able to say, okay, now I know that it doesn't affect if there's 2 toilets or 1 toilet. Well, it actually does affect the price. But anyway, I can find factors that do not affect the price of the house. And I can just remove those columns or attributes from my equation. Here, I'm trying to understand it in many, many ways. What are the factors that affect each other? So there are so many diagrams you can be using to understand the data. And when I'm finally done with my analysis, I'm ready to do my predictions. And I will do my predictions, and I find out actually, after I've done them, that the data I was using was not good enough for doing predictions, but that's another story. And being honest, most of my experiments end to this. I realized the data I was using didn't have enough attributes to really define things, or didn't have good quality data, had too much noise, had something problems with the data. Then I come back to my data and I do my analysis again and move forward. So, a more complex thing, I said earlier that I will talk about Facebook, because everybody knows Facebook. It's been in news all the time. I don't work for Facebook, so I don't know anything about Facebook, except that I have been reading articles how they do things. And I actually found it very fascinating. I disagree what they do. I don't want my data to be used everywhere without my permission and so on. But anyway, the way they do things is very, very interesting. The mission for Facebook is to give people the power to build community and bring the world closer together. That sounds very nice. If you don't think about possibility to affect elections and spying and that kind of things. But in general, that sounds very nice. They connect more than 2 billion people as of December 2017. I don't know if the number is going down now, but at that time it was a good number. And whatever they do, they could have not done it without machine learning. That's why I think this is a great example. So whatever they do, good or bad, it's about machine learning. The massive amount of data required by machine learning services presented a lot of challenges to Facebook data centers. So they have several data centers. Taking backups, disaster recovery planning, that kind of things are very complex. But I'm very happy to see in the papers that they have taken it very seriously. So they really think, what shall we do if something happens? How do we recover? So I really like that attitude, that being prepared for things. They are actively evaluating and prototyping new hardware solutions and also software solutions as algorithms. So they're kind of following both the tracks that are possible solutions for whatever problems they will face. They use machine learning everywhere. They use it for newsfeed ranking, ads, search, Sigma, Lumos, Phaser, language translation, speech recognition, and probably many more. So in newsfeed, they use machine learning for ranking and personalizing newsfeed stories. So the newsfeeds I will see in my feed are different what you will see because of machine learning. It knows that I'm interested about something else that you are interested in. By the way, I'm obviously interested about facelifts, which shocks me a bit. But anyway, obviously, Facebook knows better than I do. And I also should find a new kindergarten for my kids, which was told by Facebook. My kids are 20 and 22, but I'm sure they need a kindergarten. I'm very sure. I haven't told them yet, but I will look for a better kindergarten than the current one, the university. It's filtering out offensive content. This is something I didn't know, so it means that it's not showing me offensive content in my feed. How is it defined? What is offensive? That is a question that I would like to have an answer, but I couldn't find from the articles. It's highlighting trending topics and ranking search results and doing much, much more. So when I'm doing search, I might have a different search results as you would get. Because all the things are done with training with general models and then using my data with this trained model to give my outcomes. The ads are showing those ads that are interesting to me. So again, I will see different ads that you will see. Because about ads, the only thing is about predicting clicks. So they only get money if I go and click the ad. If I don't click it, Facebook will not get money. So it's very important for them to show me those ads that I will definitely go and click. So again, it's the generalized model they use to train, and then they use my data to find those ads that I will definitely go and click, like the facelifts. I haven't clicked any of those, and it doesn't show them anymore. So it depends on what is important, but for predicting clicks, the most important measurement is accuracy. So it has to be very accurate with the prediction, only showing me those ads that I will go and click to bring money to Facebook. So based on the experience Facebook has, is that the right features, the attributes, the columns, there's different names for that. The right features is the most crucial thing. So finding those features that will affect my selection, my age, my gender, my home country, what are those features that will affect my clickings? Finding those features is crucial. Everything else is peanuts. So even finding the algorithm is not that important than finding who I am. The right features. So using those and the right model will give them the most accurate predictions for clicks. This is how they do it. I don't go to details on this, but they are using a hybrid model structure for the algorithms to do it. So the search. It launches a series of distinct and specialized sub-searches, videos, photos, people, events, and so on, to get the search results. And there's a classifier layer that runs on top of these searches to predict which of these several searches is something that should be used. Again, the training is done offline with general data. And then when it's used in production, my data is used with the model that they just chose. A Sigma is a general classification and anomaly detection framework that they use. They use it in many, many places, and it includes hundreds of distinct models running in production every day. And each model is trained to detect anomalies. And anomalies are like something like my face recognition was. There's a lot of things, find me the faces, or find me something that is different from these faces. Find me, try to recognize, is this a number? This kind of things. So recognizing things. Lumos extract high-level attributes and embeddings from an image, and the image is content. And this data can be used as an input for something else. So if we have images, and it finds from image, this is Heli's face, they can use the fact they know it's my face as an input to something else. Phaser is the face detection and recognition framework. This is something people talk about because when you post a picture, it's immediately saying should you tag this friend of yours because obviously he's in the picture. Isn't that scary? Well, how does it know it? Because of the phaser. But what Facebook says that it only uses this for those of your friends who has allowed using phaser. So if there's a picture of your friend who has said, I do not allow you to use my face recognized automatically, it will not do it. But the tricky thing is that when they add this kind of new, do you accept things? The default is yes. So if you don't particularly go to your settings and say no, you have said yes. So that's kind of those things that I don't like the way they do, but still this is fascinating. Language translation is my favorite. It actually works pretty well nowadays, but it's been very funny, you know. In Facebook, somebody's posting something like in Norwegian, and I go and click it translates to English for me, and it's so funny. But if I translate it to Finnish, it's even funnier. So you get a good laugh with that. But now they've been improving too much. Now it's not so funny anymore. Now it's kind of translating it well. Disappointing. So, but anyway, what they used to have each combination. Finland, Norwegian, Finnish, all the languages, they used to have different process for each of these. So they decided this is too complex because there are so many languages and so many combinations. So they are trying to, probably already did it, a multi-language model that will just translate any language to any language. It will be much easier to maintain. Another thing I really love is speech recognition. It converts our audio streams into text. My husband was driving me to the airport, and on the way I was telling him that, oh, by the way, there's a new taxi company there. I haven't seen this before. And I mentioned the name of the taxi company. Do you know what happens when I open Facebook? You remember these ads? It's giving me an ad of this particular taxi company. I said, what happened? I said, it must be your phone because my phone is not listening to me. Then another time, I bought a new brand of coffee, and I told my husband, his phone is out of the room now. It's only my iPhone. And I'm saying, oh, I bought this new coffee. By the way, I don't like it very much, but this is a new brand of coffee. So in Finland, we drink a lot of coffee, and we have like 5 billion different coffees. So I mentioned the name, and what happens when I open Facebook? You all know? Yeah, it's advertising me this particular coffee. And why do you do it? I hated the coffee. Don't do it. Were you not listening well enough? I'm talking to my phone. Yeah, so obviously it was my phone listening or something. I don't know, because I didn't type it anywhere. I was only speaking. This is scary. We don't have Alexa or anything in a room, just my phone. So anyway, speech recognition understands what you are saying and is using what it learns for all these other products, like giving me those clicks. Go and buy the coffee. So Facebook is doing a lot of things with machine learning, but it's only using 5 algorithms. So you would think they are using like 1 billion different kind of super cool algorithms to do it. 5. So machine learning is about data and finding the right algorithm and keeping everything simple. That's how it works. Because if you make it too complex, you can't follow it anymore. Maybe the computer can still do it, but you cannot. So you have to be careful not to be too smart with machine learning, really, or anything else as well. So how do they do this? Well, they actually have a platform for it. They have the data. Of course, they have plenty of data. I already mentioned they are in trouble with their data centers with all this data. They have a feature store where they have those most popular features like age, gender, that kind of things that are usually used when you build a new model. They have a training thing called FBLearner Flow. They have a FBLearner predictor that will do the predictions. And after predictions, they get feedback and more data, and the process goes on and on. So they are very systematic with their machine learning. They have built a whole framework or the whole platform for them. which makes it easier. You don't have to start from scratch. Where's the data? Where can I find the data? What might be the features that are interesting, and so on. So the store has the features that might be, it's a catalog of features that might be useful in things that you do. The flow is a platform for training the model, which is important. It consists of 3 core components: an authorship and execution environment for customer distribution workflows, an experimentation management user interface for launching experiments and viewing results, and numerous predefined pipelines for training the most commonly used machine learning algorithms at Facebook. 5. The predictor is an internal inference engine that uses those models that are trained in FBLearner Flow to provide product predictions in real time. So they can train offline, and then they publish it, I don't know if that's the right word, in production to use it in real time with my data to make predictions for me. What will she click? I don't go to details on that. They also have frameworks for deep learning. So there was 2 distinct things they were doing. They used PyTorch for research, and they used Caffe2 for production. I'm sure as a programmer you already realize this is not cool. You have 2 different platforms for training and testing, and another one for production. You always program the same thing twice. Doesn't sound very nice. The reason they used PyTorch for research is the flexibility, easy to debug, and dynamic neural networks. And it's not optimized for production. It's too slow. So making the predictions in production was too slow, so they could not use it in production. But it was perfect for training because it was flexible and so on and so on. So it was very good for that. So the problem was that when they went to production, they needed to have Caffe2 for that, fast enough for production. The performance, cross-platform support, and coverage for fundamental machine learning algorithms that they really needed. So after this problem, of course, they discovered it immediately. This is not a good thing. They are smart people. They realized they will go and join this ONNX, Open Neural Networks Exchange community that was building some kind of tool between these 2, so you can kind of convert things, what you just did, to Caffe2. So it will be some kind of bridge between these 2 things. After that, it turned out to be a good solution, but not good enough. So what happened was that they started to merge Caffe2 and PyTorch together. So it would be just one environment, one platform for each of those. There's one blog post about it. So they realized that in order to deliver the best user experience, it makes sense to combine the benefit traits of Caffe2 and PyTorch into single package. Makes sense, right? So they do a lot of this kind of things to improve the world. Of course, they make money when they do this kind of things. They don't do it out of good heart. But it's good for the community because they bring new tools for us to use as well. The success factors for them. High quality data. That is number 1. So if you don't have good data, machine learning will fail eventually. So having high quality data is a success factor number 1. Complex pre-processing logic for the data, cleaning data, normalizing data, all kind of things to make the data even better. The ability to rapidly process and feed the data to the training machines was very, very important. So for all this, what they did, they needed to do a lot of research. And there's a whole page or pages full of research they have published for us all to read. Very fascinating to read. So if you want to read about Facebook's machine learning or something that even you might be using in your environment, this is a good link to go. So research that Facebook is doing. Another thing that they learned was that you should know what you are measuring to know what to improve. So if you don't know what is important, the accuracy, the speed of training, what factor is the most important thing for you, you can't measure it, and you don't know if you're doing well or if you're doing very badly. So depending what is important to you to measure is very important to define. So it depends on how we define the performance, its experimental objective. It could be class ratio, it could be accuracy, it could be error rate, it could be whatever. But you have to define what is yours. What Facebook said, they said, we noticed that the largest improvements in accuracy often came from quick experiments, feature engineering, which means that usually you reduce the number of features. Okay, her hometown didn't affect what she clicks, but the age and gender are still affecting. We'll keep them, but we'll take the hometown away from the features. So reducing the number of features for the algorithm. And the model tuning were actually more important than finding the coolest ever algorithm. An engineer may need to attempt hundreds of experiments before finding a successful new feature or set of hyperparameters. Hyperparameters, by the way, are those parameters you define before you start. Like if you're doing clustering, you define the number of clusters. That's hyperparameters. But whatever you do, this will be in the future, and this will be today. So this is definitely something you should look. Because this is, first of all, it will guarantee your job. But secondly, this is super fun. So really, this is for everybody. Because artificial intelligence and machine learning is here, and it will be here in the future as well. And there are so many interesting areas that you can learn about machine learning, not just what I told you now, but also plenty others. So just pick your area and start learning. So many languages to learn. Any language is fine. Start with the one you already know, because there is no one language we can say this will survive forever. At the moment, if you ask people, most of them will probably vote for Python. I don't know. Some will say R is the best. Some will say SQL is, of course, the best for any kind of data. But anyway, these are just opinions at the moment. If you have seen in Twitter, there's a tweet where it's showing which language has been the most popular each year. It's changing all the time. New languages coming, languages going. So if you bet for one language, probably bet wrongly. So start with a language you already know and use that. And there's also other things in machine learning than just the languages and just the things that I explained you today. There's reinforcement learning, by the way. That is the coolest ever. My research is about reinforcement learning. It is super fun. Preference learning, multitask learning, online machine learning, active learning, deep learning, adaptive intelligence, and a lot of many other things. So it's not just the basics of machine learning that we actually covered today. It's also many other interesting things. But anyway, machine learning is used everywhere. Everywhere. There is no business area that has data that couldn't use machine learning for something useful. As I explained, Facebook is using machine learning everywhere. They wouldn't be there without machine learning. It would be impossible. And you can also use machine learning anywhere. So just start small, then learn more and get more qualified about machine learning and get more excited about machine learning. You define the task and let machine learning solve your task. So machines are not taking our jobs, so we don't have to worry about that. I hear that quite often. They are just making our lives easier and more interesting. Because we can do more interesting things when the machines are doing the boring stuff. So I would be very excited about this thing, not worried about my job. With machine learning, we can understand our data better and faster, and we can make better decisions, which is very, very important in today's world. Thank you very much for attending the sessions. If you have any questions, happy to answer. But I will be outside as well, so if you want to come outside to ask questions, happy to answer. If you have any more questions afterwards, you will reach me from my email. You can read my tweets or my blog. My blog is mainly about database designing. Currently nothing happening there because I've been too busy, but I will keep posting a bit later. But you will find me from Twitter for sure. I'm very active there. Thank you so much for attending. I hope you learned something new.